Hello guys, so now I'll be explaining the topic 8 sulfur notes and their questions as well. So basically, sulfur is all about reading and memorizing, but let's do it together. Contact process, industrial manufacture of sulfuric acid. So how do we produce sulfuric acid? Sulfur dioxide is obtained by burning sulfur or roasting sulfide ores from volcanic deposits in Iran, Iraq, Poland, and Mexico. So, oxygen is obtained from the fractional distillation of liquefied air. So why do we need this oxygen? We need the oxygen for burning because you cannot burn something without the oxygen. And how is this oxygen obtained? From the fractional distillation of liquefied air. And the sulfur dioxide is obtained by burning sulfur or roasting sulfide ores. So if we're gonna do the sulfur, it will become sulfur dioxide, then sulfur trioxide, then sulfuric acid. So to make sulfuric acid, we're first gonna start with sulfur. We burn the sulfur, then we get sulfur dioxide, then it will become sulfur trioxide, then finally we get sulfuric acid. In a first step, sulfur is burnt or sulfide ores such as, I think, ink blende are roasted in oxygen. So the very first step of forming sulfuric acid is that we're gonna start with sulfur, then we will burn the sulfur with O2 to produce sulfur dioxide. Or in other terms, we have metal sulfide plus oxygen produces metal oxide plus sulfur dioxide. A metal can be any type of metal, so that includes zinc because zinc is a metal. It can be zinc, it can be iron, it can be whatever. What matters though that it is a metal. So it's a metal sulfide. Okay, it will react with two metal sulfide will react with 3 oxygen, 3O2, to produce our 2 zinc oxide, so our metal and the oxygen, plus 2 of our sulfur dioxide. So in the first reaction, we changed our sulfur into our sulfur dioxide. Now, the raw materials. How do we get the sulfur and the oxygen to make the reaction? Sulfur is mined from various parts of the world. Like they said in the beginning, it was Iran, Iraq, Poland, and Mexico. Okay, so then today a major source is from fossil fuel impurities during desulfurization. Alright, oxygen, we said, we do it from fractional distillation of air, not just any air, in liquid air. Now, in a second step, sulfur dioxide is cleaned and mixed with oxygen, and it's passed into a tower containing vanadium oxide. So in our first step, we changed our sulfur into sulfur dioxide. Now, in our second step, we're cleaning sulfur dioxide with oxygen, and then we will pass it into a tower containing vanadium 5 oxide. This will be our catalyst. Vanadium 5 oxide, okay? These gases react reversibly. So the oxygen and the sulfur dioxide will react with each other, and our catalyst will be the vanadium oxide. They react reversibly. Anytime you see reversibly, that means equilibrium. You can denote it like this or even like this to form sulfur trioxide in a 98% yield. Meaning, we did our first step here, and this is our second step over here. So we're doing what? Sulfur dioxide plus our oxygen with the help of vanadium 5 oxide, which is our catalyst to produce sulfur trioxide. Now, our raw materials were sulfur dioxide. We obtained it from burning sulfur or roasting sulfides, and then oxygen to form fractional distillation. We got it from fractional distillation of air, but not any air, our liquid air. Now, our conditions of the reaction. The temperature of the reaction has to be 450 degrees Celsius. The pressure has to be 2 atmospheres or 200 kilopascal. And our catalyst, as we said, is vanadium 5 oxide, or V2O5. Now, we finished which step? We finished step 2. Now we reach to step 3. In step 3, we have sulfur trioxide. We produced it from what? From sulfur dioxide plus oxygen. Okay, then it is dissolved into a concentrated sulfuric acid. Alright, so our reactants are SO3, which is sulfur trioxide, and our sulfuric acid, which is H2SO4, okay, to form oleum, and our product is oleum, which is H2S2O7. We call this fuming sulfuric acid. The sulfur trioxide is not dissolved in the water because the reaction is highly exothermic and to acid mist. So, what we can say from here is that we got SO3 from sulfur dioxide plus oxygen. Then we're going to put the SO3 with our sulfuric acid to form oleum. Okay, sulfuric acid is H2SO4, oleum is H2S2O7. We call the oleum fuming sulfuric acid. Now, the SO3 will not dissolve in the water. Why? Because the reaction is highly exothermic and to acid mist. It is also highly exothermic. Now, after that, we got what? Our final step 4. Oleum is transported and then added to water to produce sulfuric acid. So all of that we needed to get what? Our sulfuric acid. Okay, of the required concentration on site. So oleum is always added to water and not the other way around. So we're always adding the H2S2O7 to water, okay? And not the other way around, meaning that we do not put the 2H2SO4 into the water. Why? Because it will, it's extremely exothermic, it will cause a lot of heat, and the acid could spit out, causing severe burns. So the unreacted gases at the end of our 4 steps to produce sulfuric acid are recycled. So now we're gonna see the effect of altering the conditions on the rate of the reaction below and the reaction yield. So basically they're doing what they're doing, Le Chatelier's principle. Basically they are doing the equilibrium. So temperature, we know that it's an exothermic reaction, so if we decrease the temperature according to Le Chatelier's principle, we first start. Our imposed change is that the temperature of our exothermic decreased. According to Le Chatelier's principle, there will be a partial counteraction. Okay? This happens by increasing the temperature of our exothermic reaction, and then as a result, the concentration of our reactants decreases. So as a result, the concentration of our reactants decreases and the concentration of our products increases. Now, what happens in this case? The equilibrium shifts to the right. Why? Because the reactants are going to be giving energy to our products. Okay, so it's a forward, let me write forward or right shift. Okay, as a result, we will have a higher percentage of products, a higher concentration of products, and since the concentration of our reactants decreased, then the reaction rate will be slower. So that was for decreasing the temperature. Now increasing the pressure, look, we have here 3 gases, 3G, and here we have 2 gases. So if we increase the pressure, the reactants are gonna give to the products because they're more gases, and so then the concentration of our products will increase. So let's read what they say. It favors the lesser number of gaseous moles, so the equilibrium shifts to the right, meaning the reactants will give to our products, and as a result we will have a higher concentration of products, and And because we increased the pressure, what happens? The reaction rate will be faster because there is more effective collisions. So what is the problem if we increase the pressure? That high pressure is an expensive procedure and there may be a high risk of explosion. Finally, catalyst, as we said many times, the catalyst doesn't have any effect on equilibrium, but instead it will result in a faster reaction, but no effect on the products. So let's answer. List the raw materials that are used to manufacture H2SO4. We need what? First, we need the sulfur plus the air to produce SO2. After that, our SO2 plus the air again, taking only the oxygen, will produce SO3. Then, finally, we will get our SO3 plus our H2SO4. So, our raw materials are what? Sulfur plus the air, taking into consideration only that we're using the oxygen. So list the conditions used in the contact process. Okay, the temperature of the contact process was 450 degrees Celsius. The pressure was 2 atmospheres or 200 kilopascal. And then the catalyst was vanadium V, meaning 5-oxide. And then finally, they're asking us in part C, write an equation for the catalyzed reaction. It's gonna be sulfur dioxide plus oxygen gives us SO3. Is it balanced? No, it's not balanced. So to balance it, we are gonna put a 2 over here and a 2 over here. So this is the equation for the catalyzed reaction. Anyways, it was over here. Alright, so the equation for the second step in the contact process is this. Now the percentage of sulfur trioxide in the equilibrium mixture changes with temperature. So they're telling us how does the percentage of sulfur trioxide change in the equilibrium mixture as the temperature increases? By looking here, as the temperature increases, the percentage of sulfur trioxide decreases. So the answer here is decreases. What is the effect of increasing the temperature and increasing the pressure on the position and equilibrium? Here we have 3 gases, here we have 2 gases. So if we increase the pressure, then definitely the reactants is gonna give to the products. So there is a right or forward shift in the position if we increase the pressure. However, if we increase the temperature, we know it's an exothermic process, so we're gonna put heat over here. So if we increase the temperature, according to Le Chatelier's principle, as a partial counteraction, it will decrease. And so to lose the heat, it will have to give it to the opposite side, which is the reactant. So our products are giving to our reactants. We call this a backward or a left shift. So that is for CQD number 2, part A. Now part B. In the following reaction, okay, is the forward reaction exothermic or endothermic? This is our forward reaction, meaning till here. So they're asking us, is it exothermic or endothermic? We said, by looking at the graph, as the temperature increases, the percentage of sulfur dioxide, trioxide, decreases. So by looking at the graph, if you have the temperature as it increases, the products decrease, it is exothermic. But if you have a graph like this, and here's the temperature and here is the product, if the temperature is increasing and the product is increasing, it is endothermic. So here the temperature is decreasing and the product is the temperature is increasing and the product is decreasing, so we say it is an exothermic reaction. So, the temperature used in the contact process is 450 degrees Celsius. Explain in terms of rate and percentage yield why this temperature is used. It is, I believe, the minimum temperature. Alright? So it will be like the minimum temperature to produce. Alright? And it is high enough, like big enough to produce a good amount. That was for C. Now for D. Explain how sulfur trioxide is converted to concentrated sulfuric acid. All we need to do is fill in the blanks. So sulfur trioxide plus H2SO4, this is dilute H2SO4, will give us this. Then H2S2O7 plus H2O will give us concentrated H2SO4. So that's CQD number 2. CQD number 3. Consider the following equations that show a possible route for the formation of sulfuric acid as part of acid rain. Which of the two equations represent a redox equation? I don't think we took this, so we don't have part A. 3A not included. Okay. Now, an alternative way to produce acid rain through the reaction of SO2 with water, rain first, then through the reaction of the product with oxygen gas, are the two equations that are involved in this reaction. So we said SO2 with water. So it's going to be SO2 gas plus H2O liquid will give us H2SO3. H2SO3 what? It is a solution between gas and liquid, so I think aqueous, alright? And then after that we said we're gonna take the H2SO3, which is our acid rain, and then it will be mixed with oxygen gas to produce our acid, now our sulfuric acid. So H2SO4, not our sulfuric acid, sorry, our acid rain. So this isn't balanced, so let me balance it now. This over here will be 1/2. So again, please memorize the equations. They're very important, especially for CQD number 3. Now CQD 4. Sulfuric acid H2SO4 is manufactured industrially by the contact process. After reacting molten sulfur with air in large furnace, the sulfur dioxide gas SO2 produced is mixed with more air to make sulfur trioxide gas. Give the chemical reaction between sulfur dioxide and air. Okay, easy. It's SO2 plus O2 gives us what? SO3. If we want to balance it, this would be 1/2. Okay? Now, B. What are the conditions of pressure and temperature to produce SO3 in this process? Again, temperature was 450 degrees Celsius. Pressure was 2 atmospheres. So, 2 atmospheres. Give the name of the catalyst used. It was vanadium 5 oxide. Now, last question. Great. We have CQD 5 top. The manufacture of sulfuric acid. Oh my goodness, guys, this is really easy, okay? Don't read, just like we know it's the contact process. The contact process is what? SO2 plus O2 gives us SO3. We have the catalyst, we have the temperature, and we have the pressure required. So they said define a catalyst. What is a catalyst? Just biologically, it speeds up forward and backward reaction rates without being consumed. Yeah, and now we define the catalyst. Define the catalyst used in reaction 2. What was it? Sulfur dioxide combined with oxygen. As soon as you see sulfur dioxide and oxygen, know that the catalyst is vanadium 5 oxide. Now, write a balanced equation for reaction 2. If we're going to write it, it will be SO2 plus 1 over 2O2 will give us SO3. Alright? Now, write a balanced equation for reaction 4. We have oleum is then diluted with water. Oleum is H2S2O7 is diluted with water plus H2O will give us sulfuric acid, which is H2SO4. Now, D. In reaction 2, less sulfuric trioxide forms at a higher temperature. Specify whether reaction 2 is endothermic or exothermic. Alright, sulfur trioxide in reaction 2 is what is our product. So as we increase our temperature, our products are decreasing. So then we say this is an exothermic reaction. And that is it for the the topic 8 sulfur notes, and I hope you guys enjoyed.